To make an ice pack, we will need 68 grams of baking soda and 300 grams of citric acid from lemons. Using a fruit squeezer, squeeze the lemons to extract the juice from it. Filter the juice collected to remove any pulps and seeds present. The filtrate will contain citric acid, C6H8O7. Measure 4.0 grams of baking soda, around 2 teaspoons, which is also known as sodium bicarbonate, and pour it into a Ziploc bag. Using a syringe, measure 50 cm cube of citric acid and pour it into a plastic bag. Ensure that the plastic bag is big enough to hold the citric acid. Using a measuring cup, measure 100 cm cube of tap water and pour it into a container. Using a thermometer, measure the initial temperature of the water and record it in a table. Place the bag containing citric acid into the Ziploc bag containing the baking soda. Put pressure on the plastic so that the citric acid can escape and react with the baking soda. Shake the Ziploc bag. Place the Ziploc bag into the container containing the 100 cm cube of water. There will be an endothermic reaction taking place. Using a thermometer, measure the lowest temperature of the water and record it in a table. Calculate the decrease in temperature and record it in the table as well. As the experiment shows, the temperature of water decreased from 31 degrees Celsius to 29.5 degrees Celsius, thus achieving the target change in temperature. Citric acid is found in lemons while sodium bicarbonate is found in baking soda. Energy is taken in when citric acid found in lemons dissociate in water to break bonds in 1 mole of citric acid. It is also a weak triprotic acid as it will dissociate partially in water to form 3 hydrogen ions for every molecule of the acid. Energy is also taken in to break the bonds in 3 moles of sodium bicarbonate to form 3 sodium ions, 3 hydroxide ions, and carbon dioxide. After the breaking of bonds in citric acid and sodium bicarbonate, energy is released to form bonds. This is because hydroxide ions from sodium bicarbonate will react with hydrogen ions from citric acid found in the solution to form water and carbon dioxide as energy is taken in. The overall ionic equation is shown in the video. However, the energy released to form bonds in the products such as carbon dioxide and water will be more than the energy taken in to break bonds in the reactant particles such as citric acid and sodium bicarbonate. Therefore, this is an endothermic reaction as more energy is absorbed to break the bonds of the reactants than the energy released when the bonds of the products are formed. The resultant enthalpy change calculated is positive 3,460 joules per mole.